Okay, so chapter 5, probability distribution. Probability distribution. Okay, so before I get into this, I need to define some variables or some terms. So what is a variable? Variable is nothing but a characteristic which can assume different values. Different values. What is a random variable? Now, before that, um, can you give me some examples for the variables? Any example for the variable? You have seen in your lab slide, right? When you're doing your GMP, you have something like a column like this, subset of small term here, and you have a big heading where it says age, height, weight, etc. Right? So those are called as variables. Okay, those are called as variables which has a different values. Age, weight, etc. All those who is holding all those values, that is called as variable. What is a random variable then? So variable means which is holding different values. Then what is random variable? Variable those values, if those values are determined by chance, it's called as random variable. Okay, any example for this? You have did this in your, I guess, lab 4. You have come up across this word, random variable or random binomial variable. Any guess? You did this in your lab 4. Rowlett. Okay, so if you want, chapter 4, if you go to assignment question, so if you see in line number 4, they say consider a simulation using a Bernoulli random variable. So and that random variable, we defined it as Rowlett. Okay, we defined it as Rowlett in lab 4. That is where you have seen the random variable. Now, what did we do in lab 4? We just renamed it as Rowlett and we applied some formula, right? And what values did that hold? You remember? So what values were that having? Only 0 and 1. It had only two values, which was 0 and 1. Okay. Now these two values are determined by chance. Chance of winning, chance of losing. So and that is why we call that as random variable. Now we call that as Bernoulli random variable. That is only because it is having two unique values. So if any variable has only these two values, not any decimals, it should be only 0 or 1. So if it is holding either of these values, then we call that variable as Bernoulli random variable. Okay. Then what is discrete? You studied this in chapter 1. Discrete variables are nothing but the variables which you can count. Okay, that is called as discrete variable. Now what is discrete random variable? Which has finite number of, it is the same meaning but in a different version. Finite number of possible chances of values. Possible values. That is called as discrete random variable. Okay. Then what is discrete probability distribution? You will be studying this in your lab 5, right? So discrete probability distribution. A distribution which consists of a distribution consists of the values. What values? Values of a random variable can assume, and the corresponding probabilities of those values. Okay, so these terms you have to remember in order to study chapter 5. So I'll just give a minute so that you can write. Done? Okay, so introduction. Now, in chapter 2 and 3, we studied about frequency distribution table, right? Frequency distribution table. In chapter 4, we studied about probability. In chapter 5, we are studying about probability distribution. Okay, combining chapter 2, 3, and 4. Now we know that frequency distribution looks something like this: X, F, right? So this was frequency distribution. Now, how does a probability distribution table look like? Scratch off this F. Instead of that, we have probability. That's the only difference. So it is a combination or a mixture of frequency distribution table with the probability. You will be replacing frequency with P of X. That's all. Okay. So I will not go much into this. So we defined all these variables, terminologies, discrete random variable. Now continuous means infinitely many values. Discrete means finite number, continuous means infinitely many values. Okay. Now I'm leaving this example 1 for you all to answer. You just have to answer which is discrete and continuous. You all have did this in your chapter 1. So just take a minute to answer those questions. Okay. Now, what are the requirements for a probability distribution? So if you want to tell the distribution as, if you want to classify that as a probability distribution, then what is the requirement it has to satisfy? So there are only two requirements. That is, the summation of P of X must be equal to 1. Okay, and second rule is the p of x values must lie between 0 and 1. So this we already studied. Now, first rule. Any idea that where have you seen this number? Summation of p of x equal to 1. It is similar to something. And you studied that in chapter 2 and 3. Exactly. Very good. Summation of f equal to 1. Right? Because percentage frequency, or should call this as relative frequency. Okay, relative frequency was equal to 1, or in percentage wise, it was 100%. In the same way, just replace frequency with probability. Then when you add all the probabilities, you have to get the value as 1. Okay, so let us do some problem. Now, they have given x and p of x, also called as probability distribution table. Okay, probability distribution table. Now we have to check whether this is a probability distribution or not. Yes or no. That's it. Yes or no. So how can we check whether this table belongs to that? You have to check two things, or even one thing. That's also fine. So first one was summation of p of x must be equal to 1, right? Now for this table, will that hold? Is summation of p of x equal to 1? No, right? It is not equal to 1. So you don't have to go for the second requirement also. So here I can conclude that no, it is not a probability distribution table. Okay, very easy. You will have some similar kind of problems in your test too. You will have this. Okay, remember, you don't have to calculate anything when this type of problems are there. You just have to calculate the total of probability, and if it is equal to 1, then go for a second requirement. Okay, now for example, there is no 1.57 here. I have 1. Okay, and I have 1.50 here. Imagine, I know that this will not be a case at all, but just imagine that this is 1.50 and your total is 1. Now, according to requirement 1, number 1, summation of p of x equal to 1. Yes, that's true, right? Now go for the second requirement. That is, each value must be between 0 and 1, right? So this is between 0 and 1, this and this, but when you see this is greater than 1. So it does not satisfy the second requirement. So you cannot tell it is a probability distribution. Okay, so if you check the requirement number 1 and it satisfies, go for the second requirement. That also should satisfy. Okay, now answer these questions. I will leave this to you. Check whether this is a probability distribution or Do I have answers in the chat box? Done? Okay, so what is the first answer? What is the total? And write it as mentioned. 601. Correct. And so I can easily say that the first one, this question A, is yes. Is probability distribution. Probability distribution. Okay. And the second one is definitely no. Why? Because summation P of x, because summation P of x is not equal to 1. Now, tell me the answer for third one. Do you think it is a probability distribution? No. Okay. Now, summation P of x is equal to 1.001, right? Now, for example, usually when we write a decimal, we take at least one number, right? Suppose if this is like a continuous number, we take just a starting number and just leave the rest of them. Now tell me whether it is a probability distribution or not. Yes, right? So when you have a round of error like this, the answer must be yes, because there are chances that it is a probability distribution. Yes. Okay. Example 4. So there is a coin which is tossed 3 times. Okay, 3 times. That is nothing but trial, also called as number of times it is tossed. Now, what we do, what we are supposed to find, the probability of number of. Okay, so let us solve the first problem. Find the sample space. Now we are tossing a coin 3 times. So what might be the chances? First time I get head, second time, third time. Okay, so let me write like this. So first time, the second time, and the third time. Okay, I might get head here. All the 3 times I might get head, or it can be tails, or it can be head, tails, and head, tails, head. You just have to shuffle. Tails, head, and head. What might be the other combination? Two tails and a head, or this is over. There are two THT. THT. Good. THT. And there is only one left out. THT, TTH. HT. Okay, so I guess I have not repeated anything here. Now, if you count this, there are 8 outcomes, right? 1, 2, 3, 4, 5, 6, 7, 8. Now this is called as sample space, all the outcomes. Okay, so let me write this. Actually, keep this here. Now to answer the A, sample space will be equal to head. I'm just rewriting the one which we did. Okay. Use head. Let's do it. So this is our sample space. Now B, you are supposed to construct a probability distribution table. Probability distribution table. Okay. Now, as I said to you before, it consists of only two columns, that is x and p of x. Okay, x and p of x. Now, what is x? Number of heads. Okay. So, number of heads can be 0, which means there is no head at all. It could be 1, it could be 2, it could be 3. Now, I'm stopping here. I'm stopping at 3. Why? It is because there is only 3 trials. So, maximum number is 3. It cannot go above that. So, it is 0, 1, 2, 3. Now, we are supposed to find out the probability of 0, which means what are the chances that there is no head at all? 1. Okay, 1 out of total outcomes, that is 8. What are the chances there is at least 1? How many do we have? 1, at least 1 head, 2, 3. I guess that's it. So this is going to be 3 by 8. Now, what is the value for the probability of 2 and probability of 3 head? Yes, 3 by 8 and 1 by 8. That's it. So if you add all this, you will get answer as 1. Summation of P of x will definitely be equal to 1. Okay, so this is how you construct the probability distribution. Now, answer C. Construct the histogram. Okay, now the problem here is you do not have a class interval, rather you have just the actual value. So how do you construct the histogram? So let me write the x and y axis here. Okay, so this is 0, 1, 2, 3. So 0, 1, 2, and 3. Okay, and what values do I have? 1 over 8, 3 over 8. So this 1 over 8, 2 over 8, 3 over 8. Okay, I'm going to stop there. Now, at 0, the value is 1 by 8. Right? So at 0, it is 1 by 8. So my point is somewhere here. Somewhere here. For 1, it is 3 by 8. So it has to be here. And for 2 also it is 3 by 8. For 3, it is 1 by 8. Okay. Now, I will join this. Is this the histogram? This is not a histogram, right? So histograms means you must have a horizontal bars. Now, how can I construct? Maybe I can draw a straight line. Is this the histogram? No, we just have a vertical line, right? Now, how can we construct the histogram when class interval is not given? So what do you think these values are? These are not the class intervals, but these are the class midpoints. Okay, class midpoints. So whenever you have such values, give a 0.5 offset, or I mean a gap between the values. This is the midpoint, and I will give a gap. So likewise, if you do for the other problems, you will get something like this. Okay, this is how you construct the histogram. So I'll stop here and can continue the rest of the problems